first thing, I have it up here on the board. If you, I think the biggest thing that trips people up on this type of question is that most of the time when we're talking about integrals and derivatives, we are talking about like rules for functions that are put in front of you. But on questions like these, that's not the case. They don't give you a function. So then we need to figure out the kind of definition of derivatives and integrals and what information they tell us. So on a very basic level, integrals tell you area. That's why we use Riemann sums with our rectangles and trapezoid areas to approximate integrals. Because integrals will tell us area. So if it's a question about the integral of the graph, then we're going to be talking about and calculating out areas. If it's a question about the function, well, that's easy. We just look at the y-coordinate. And then if it's a question about the derivative, remember, measures and tells us the slope of the tangent line. So when you're looking at a derivative and being asked about if I have the graph of f there, if I'm ever asked about f prime, then I want to think about slopes. And literally calculate out change in y over change in x. So integrals, we're going to think about area. The function, we're going to think about the y-coordinate. The derivative, we're going to think about the slope. And let's take a look here. First off, g is the integral of f of t. So the first thing that you should kind of write down on this type of problem is that when I say f, that means in terms of g, that this is the graph of g prime. Derivatives and integrals are opposites of each other. So if I know that g is the integral of f, that means the derivative of g is f. So that's the first thing. But let's take a look at part A here. Find g of 0 and g prime of 0. G of 0. That means that we are plugging in 0 for x. And where is x? X is in the top bound of my integral. -3 up to 0 of f of t dt. By the way, don't forget, if instead of -3 to 0, it were from 0 to -3, what would you do? Flip the bounds and make it negative. So watch out for that if that comes up in a problem. Yeah, yes, if I started with 0 to -3, I would switch and make it -3, 0, and put a negative out in front of this. Integral from -3 to 0. That means I start at -3 and I end up at 0. I want this area. Integral means that I should be looking at area. Starting at -3 and ending at 0. So I'll give you just a minute to slice up that area, calculate it, accumulate it out together however you want. Give you 1 minute to do that. So whether you did this by splitting up trapezoid or just doing the area of the trapezoid, you should get 9/2. And again, that's just area. Part B. Oh, not part B yet. It also asks for g prime of 0. G prime of 0 is nice and easy. All you need to write down g prime is f. So I just want f of 0. This is just testing your knowledge that G prime is F. And if I just want F, then I just look at the Y coordinate. What's the Y coordinate? It's 1. Done. Free point right there. All right. Part B. Find all values in the open interval from -5 to 4 at which G attains a relative maximum. So my explanation or my advice on this is always that you should write the explanation first. Notice I'm not showing the graph right now because I don't want you thinking about the graph. I want you to do all the calculus thinking first, and then we will do our, oh, just look at the graph part of it. So you're not trying to wrap your mind around 5 things at once. So start, and that way you remember to justify your answer as well, which is going to ask you to do. So here comes your justification. Before I've even found where it is, here comes my justification. G of X has a relative maximum where, finish that sentence. Give you 30 seconds, finish that sentence. One key thing in the explanation, this idea that F is G prime is something you need to say in your justification. If you just say this is where F does this, I'm going to ask, well, I'm asking about G. What does G have to do with F? And so you need to say, well, F is just G prime. Oh, now I know what G has to do with F. So you'll see in the explanation, I say G prime of X is F of X. So now I have connected G prime to F. And since that's the derivative, we have a maximum when the derivative changes from positive to negative. And now I can just look at the graph and see where it changes from positive to negative. Bingo! That's where we change from positive to negative. So at X equals 1, 2, 3. Making sure I counted right. That's part B. Part C, absolute minimum. This sentence is going to be the opposite of the other sentence. Okay, hopefully we have that. And I had a whole day earlier this week on absolute max and min. So hopefully we remember the steps of how to do that problem. But we're going to reinforce it here. See, it's coming back. It loops back around. So first off, we need to figure out where our minimum is. Which will be, oh. That's where we change from negative to positive. This we equal 0, but never change from positive to negative or negative to positive. So we don't consider 1. We consider -4. And then remember that we want to consider the endpoints as well. All right. So we have 3 points that we need to consider. We need to consider the endpoints of -5 and +4. And then we need to consider our point that we just found of -4. So let me give you about 2 or 3 minutes to figure out what each of these values are. Okay, hopefully, first of all, hopefully we figured out that this area is this area here is 1, right? And then this this area here is a -1. So then we already figured out this area was 9/2. Hopefully we figured out that these two areas are going to cancel each other out. They're 1/2 and -1/2, and they cancel each other out. Now, the tricky part is this area right here. So first off, most of you have noticed that we have a semicircle. So we have half a circle, so that's going to be 1/2 pi r squared. Our radius is 1, halfway across. So that is pi over 2 is our area of the circle. Bad news though. We want everything but the circle, because we want this area down here. So the way that we're going to do that is that we are going to take this rectangle here and then subtract out the half circle, and what's left will be the area that I'm interested in. So the area of the rectangle is, that's a 2 by 1 rectangle, so my area is 2 minus pi over 2, and that is my area of that semicircle. So my first off, g of +4 is 9/2 plus the 2 minus pi over 2 plus 1/2 minus 1/2. And then figure out what that is. -5 is going to, the area out from -5 to -3 just cancels each other out. So 0. How many got 0 as the -5 area? You guys got it? Okay. So hopefully that makes sense that this area is the same as this area. And so really we go nowhere. Now, tricky part. 2 different ways to show the integral to, from -4. As I said, the area of this triangle is 1. But first of all, let's think about it this way. What is g of -3? Why? Yes? Okay. So at here, I'm at 0. So at -4, I'm trying to figure out where -4 is. Well, I don't know that yet, but I do know that I end up at 0 when I get to 3, or to -3, and I had to move up 1 to get there. So if I started at this mystery place, but I tell you I moved up 1 to get to 0, where did I start? You started at -1. Does that make sense? The other way to think about it, if you want to just think about it like, not algebraically, but calculus-wise, the way, if you want to think about it in terms of your kind of rules of integrals, this is where it would be the integral from -3 to -4. And so this is where we would say, oh, instead of from -3 to -4, that's in the wrong direction. So let's flip those and make it negative. So negative, and then the area of this triangle is +1. So -1. Questions on that? Okay. F has a point, or sorry, G. It's asking about G. G has a point of inflection. And this is the kind of thing that we'll practice on our Kahoot after school. When G double prime changes sign, changes from positive to negative or from negative to positive. That means that the first derivative has to change direction from increasing to decreasing or from decreasing to increasing. So it's when our first derivative has a max or min. Because then the derivative of that function, if G prime has a max or min, that means G double prime, the derivative of that would change from positive to negative or from negative to positive. So your explanation would probably look like G has a point of inflection when G prime, which is F, has a maximum or a minimum. Okay. All right. Let's try one more problem here before we go. And I want you to look at part A here. So I'll actually make this bigger so you can see it better. All right. Start by worrying about the areas. And then we'll talk about where the 2x comes into play. So take about 2 minutes, and it's asking for -3. So take -3 and figure out the integral for there. So first of all, in order to switch the bounds, you got to make it negative. This is a quarter circle. So our radius here is 3. So a quarter of pi times 3 squared will get us 9 pi over 4. So -9 pi over 4 is our integral. Now, let's deal with actually finding G of -3. Here's G of x. So that equals 2 times -3 plus that integral. I'm just plugging in a -3 wherever there's an x. Yes? Okay. So 2 times -3 is -6. We decided this was -9 pi over 4, so minus 9 pi over 4. G prime is easier. Derivative of 2x, don't lose me here. Derivative of 2x is 2. Derivative of that integral, So plug in -3, and I get 2 plus f of -3, which is 2 plus f of -3 is 0.